Hello, my dear students. Let us take one more example. Uh, a cantilever of length 2 meter carries a UDL of 1 Newton per meter run over the whole length and a point load of 2 kilonewton at a distance of 0.5 meter from the free end. Draw SF and BM diagram. Okay, so this is the given beam AB. One end is fixed and other end is free. So cantilever beam of length is 2 meter. Total length is 2 meter, and here one UDL which is acting over the whole length, that is 1.5 kilonewton per meter, and one point load is there, that is at C. Okay, now first what we have to do, we have to calculate the shear force values at different points. Let us start with the right side. See sign convention. What you can do, no, always in one corner you can draw that shear force sign convention. Okay, so this is positive shear force, means when you consider from right side downward is positive and left side upward is positive. Similarly, negative is right side upward is negative, and also left side downward also negative. Okay, so let us consider here. So first shear force at B, that is what here, there is no loading, nothing. So shear force at B is 0. Okay. Next point, this is the section I have considered here. Okay. This is just imagine. You just no need to draw. If you want, you can draw. Okay. Next, shear force right to C here. See here, there is one UDL which is acting here, right to C, at a distance of 0.5. So what is that now? Shear force just right to C is, load is UDL of 1.5 kilonewton per meter, 1.5 into 0.5, because you are considering right to C, that is 0.5. Okay, 1.5 into 0.5, that is equal to 0.75. Next, shear force at C now. Shear force at C is, till here it is right to C is 0.75. 0.75 plus 2. Why plus 2? This is right side downward, right side downward is plus, correct, according to this. Okay, this is the right side downward is plus, so plus 2. So 0.75 plus 2, that is equal to 2.75. Next, shear force section is here. Now shear force just right to A. Okay, what is that? 2.75, till here it is 2.75. 2.75 plus, again it is downward direction, so downward is 1.5 into, now you have to consider only A to C. What is the distance? That is 1.5. So 1.5 into 1.5. Okay, so that is, when you add that, you get 5 kilonewton. Why this is 1.5 into 1.5? This is UDL, you have to convert into point load, so that is 1.5 into 1.5. So you get 5 kilonewton. So shear force just right to A is 5 kilonewton. So shear force at A also equal to 5 kilonewton. Okay, next we'll see how to calculate bending moment. Okay, so next see bending moment at B. What is bending moment? This is the diagram. Bending moment at B is equal to 0, because there is no load, no perpendicular distance. X is equal to 0 here. Okay, so bending moment at B, and B is equal to 0. Next point is bending moment at C. Okay, so what is bending moment at C? Bending moment at, or you can consider bending moment right to C also. Okay, because here UDL is there. So bending moment just right to C is, what is that? 1.5 here. This is 1.5. Okay, this is acting here, we are considering till here. Okay, so that is 1.5 into 0.5 into half of 0.5 because it is UDL. So force into distance that you convert into load. Then again you have to consider this is moment. So force into perpendicular distance. So half of 0.5 that you have to consider 0.25. So that's why it is written here minus 1.5 minus 1 point. This here also it is 1.5 only. Okay, it is full length, it is 1.5 only. So 1.5 into zero point 0.5 into zero point 0.5 divided by 2. Okay, that is just right to C. Next, at C, what is at C now? This is there anyhow, 1.5 into zero point 0.5 into zero point 0.5 divided by 2 minus 2 into at C only. Perpendicular distance is 0 now here. So into 2 into 0, that is equal to, when you simplify this, you get minus 0.1875 kilonewton meter. Okay. Next, at C is done. Next, bending moment, just write to A. Okay. What is that? Just write to A here. That is uh, 1.5 minus 1.5. Why minus? Because the direction right side is like this. It is minus and this is plus, correct? So I'm considering from the right side. So minus 1.5 into this distance now. Okay, shear force at A till here you can consider. So that is 1.5 into 2 into half of 2, that is 1 minus, again this point load is there, that is 2 into this distance, that is 1.5. Understood no? See, first you consider this UDL. UDL is of full length, right, here till here, that is what, 1.5 into 2 into half of that you have to consider, because this is bending moment. So force into distance is there, so that half of 2 is 1, and again one point load is there, that is 2, and that is acting at C. So 2 into this distance till A you have to consider. What is that? 2 into 1.5, that is equal to minus 6. So bending moment at A is equal to minus 6 only. Okay, so like this you can calculate what is bending moment. Then draw bending moment and shear force diagram. How to draw shear force diagram? At B, shear force diagram, at B it is 0, then just right to C is 0.75. Okay, so that is 0.75 here. This is why this is linearly changing. You can see here, this is changing from 0 to 0.75. Okay, UDL, that's why it is like this. Okay, then 2.75 to here, this is 2.75, total it is 2.75. So till here it is 2.75. Okay, here 0.75 plus 2, that is 2.75. Okay, here this is 2.75. Next, between C and A, or just write to A, that is equal to 5. Okay, so just draw here 2.75 to 5. Then at A, that is also 5. Okay, till here it is 5. So 0 to 0.75, 0.75 to 2.75, 2.75 to 5, then at A is 5. So all are positive values. So this is plus. Okay, this is shear force diagram. Then draw bending moment. How to draw? Bending moment at B is 0. Here no need to consider, just write to C. Okay, just if you want you can consider, or directly you can go to that particular point only here. Okay, that is at B it is 0. Then at C, that is equal to minus 0.1875. Here minus 0.1875 below the line, minus. Okay, then it is equal to, at A, that is 6, and here this is full curve. Okay, parabolic curve. A to C also parabolic curve, and C to B also parabolic curve, because it is UDL. So here 0 to 1.875, then 1.875 to 6 parabolic curve. So like this you can draw a bending moment diagram. Okay, see, I hope all of you understood. Mainly you have to remember sign convention. Okay, for bending moment these are the sign convention. This is right side, this is left side, this is right side, left side. Right side clockwise minus, right side anti-clockwise plus. Okay, suppose I usually consider from right side only, so you just remember the right side sign convention. And even shear force also, that is right side upward is negative, and right side downward is, left side downward is negative. Or right side, you just consider this right side downward is negative, or left side upward is positive. You just consider this right side and this right side upward negative, right side downward is positive. Just you remember, because I always start the problem with the right side. Okay, so right side downward plus, right side upward negative. I hope all of you understood. I'll give one example. You just try this, how to do this. Okay, a cantilever 1.5 meter long is loaded with a uniformly distributed load of 2 kilonewton per meter run over a length of 1.25 meter from the free end. It also carries a point load of 3 kilonewton at a distance of 0.25 meter from the free end. Draw SFT and BMD of the cantilever. Okay, this is a cantilever. A B of length is 1.5 meter, and here one UDL is acting, that is 2 kilonewton per meter. Okay, and here point load, that is 3 kilonewton, which is at a distance of 0.25 meter. Okay, you have to draw now this SFT and BMD. Okay, first find at B what is shear force at B, then what is shear force, just write to C, then shear force at C, then shear force just write to D, and shear force at D, then shear force at A. Okay, then bending moment at B, what is bending moment? Bending moment at C, then bending moment at D and A. Okay, do this calculation and try to draw SFT and BMD also. We'll discuss in the class. Thank you.